So yesterday we talked about triangle congruence, and the important thing you took away from yesterday's lesson was that if I tell you triangles are congruent, it means all of the individual corresponding pieces must be congruent. That was corresponding parts of congruent triangles are congruent, or CPCTC. And the question that I left you with yesterday was, do I need to know all 6 parts? Do I need to know all 3 sides and all 3 angles to know they're congruent? Or is there a way I could get away with fewer pieces of the triangle and still know that the triangles are congruent? And the answer is yes, there's a bunch of ways. We're going to learn about 5 of them. And the first one we're going to learn is called SAS, which stands for side, angle, side. Meaning I could prove 2 triangles were congruent if the only thing that I knew was that they had 2 corresponding congruent sides and 1 corresponding congruent angle. The trick is it can't be just any angle. It has to be a specific angle in the triangle. And the name of the specific angle that it has to be is what is called an included angle. And the definition, very quickly, is the angle formed by 2 given sides. That is an included angle. And I'm going to give you a couple of examples here. So in this triangle that I just drew, triangle ABC, you'll notice I've indicated angle C. Angle C is the included angle between which 2 sides? Yes. Angle C is the included angle between side AC and side BC, or CB if you like. I can take the exact same triangle, and here I'm going to do a perfect copy of triangle ABC, indistinguishable from the first one. And I'm going to indicate a different angle, this time angle A. Angle A is the included angle between which 2 sides? B and A aren't sides. CA and AB. Right. So I'm going to say AC and AB. AC and AB, those 2 sides meet at angle A.
So those 2 are congruent angles, right? The 2 that you drew, they're supposed to be congruent.
No, I'm just indicating which angle I was talking about. So the theorem that we're going to learn today, and there's only one, I'm sorry to say. I know. Tomorrow we'll learn 2. It's called the side angle side congruence theorem. And the side angle side congruence theorem, also known as SAS, says this. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. They must both have the included angle. If it's not the included angle, it's not SAS. That's the reason we write SAS. The angle is between the two sides. It's the reason we write it in that order. Plus, if it's not the included angle in between the two, then it spells a naughty word, and you know we'd never write that in math class. The angle must be between the two sides. If it's not the included angle, it does not meet this congruence theorem. So I'm going to give you a couple of pairs of triangles, and I want you to tell me whether or not we have enough information to prove that the two triangles are congruent. Now you can't go just based on the pictures. You can't look at the pictures and say, those look like they're the same. I know from my pictures, it looks like you could do that because they're all flawless. What do you mean, actually?
I mean, they were okay yesterday.
I mean, the track was a little
Icky.
It's okay, Mr. Taylor. Some days we just can't win.
And we're telling you the truth. We have to, we're not lying.
So first of all, question number one, can I use SAS, or the side angle side congruence theorem, to prove that these two triangles are congruent? Do they have two congruent sides and the included angle is congruent? Yes. So we could say these are congruent by SAS. Now, follow-up tricky question. How do I write that? How do I write triangle such and such is congruent to triangle such and such? Remember yesterday we said the order matters. They have to have the correct order. So if I take the first triangle, I'll just call that whatever, PQR. It would be inappropriate for me to say it's congruent to triangle EFG just because those are in alphabetical order. I don't know that the congruent sides were put in alphabetical order. In fact, since I'm writing this problem, you know I like to not put them in alphabetical order just to make you mad. So I have to put the letters for the next one in the same order. Okay, so the first two letters that I have are PQ, which is this side right here, PQ. the side with one diddly-do showing it's congruent. Look at the other triangle. Which side of the other triangle has the one diddly-do? EG. Okay, but I can't just write that because the question is, should I write EG or should I write GE? Because what's the same? How do you know that G and P are the same? Exactly right. Q and E are the congruent angles. So Q and E must be in the same spot. Since Q is in the middle in the first triangle, E must be in the middle of the second triangle, which means instead of EG, I must go GE. I don't really have to stress about the third one. There's only one letter left. It has to be F. Since I now have proven by SAS that these two triangles are congruent, I could go ahead and go the rest of the way if I wanted to. I could say, well, P and G are in the same spot, so P and G must be congruent. R and F are in the same spot, so R and F must be congruent. And of course, there's only one side that I didn't know was congruent, so I know PR and FG must be congruent. Because if I know side angle side, I know everything else has to be congruent as well.
Wait a second. G's 2, F's 3 or 4?
G's 2, F is 3. We don't ever do 4 in a triangle. Well, Emily might do 4 in a triangle, but normal people don't do 4 in a triangle because you only have 3 angles.
Well, you know, okay, so when it's a square, we do 4 angles?
If it's a square, you could, yes. Or really any quadrilateral.
Oh, that's cool.
Yes, yes, I am.
Like a piece of paper.
God bless you, my child.
This is cool.
Hmm?
I like this.
Oh, good.
Is it kind of like how you would do the parallel lines cut by transversal?
Interesting. If I knew those lines were parallel, yes. I don't know they're parallel, though. They don't have the diddly-doos. They have doodly-dids. She said if US and VW were parallel lines, UW would be a transversal, and you could figure out some angles that way. And she's right, but I don't know that US and VW are parallel. We could just completely change this problem so that it was easier.
Yeah, we could have, but you won't.
But my question is, can I prove that these two triangles are congruent? Why not?
I see.
Very good. The congruent angle is not the included angle. So these are not, I'm not going to say they're not congruent. I'm just going to say they're not able to be proved congruent. They might be congruent. I just can't prove it. These are not able to be proved congruent because the congruent angle is not the included angle.
Is there an abbreviation for included?
INC period.
Right.
It's not the incorporated angle.
Angle.
This angle is a suburb of a big city. It is not incorporated.
Maybe one day.
So are these triangles congruent? I don't know, maybe. But I can't prove that they are congruent. So my answer would be, I have to assume they're not congruent unless you give me some more information to prove that they are.
Could you prove they're congruent with a different theorem?
No, there is no triangle congruence theorem that is angle side side with a non-included angle. Because then you would have to write a naughty word in math. Well, number one, it doesn't work. But then number two, then you can write SSA, I guess. But even then, it doesn't work. It's got to be the included angle. Otherwise, you can't prove they're congruent. Hey, speaking of proving things are congruent.
Don't tell me we're doing it true.
Okay, I won't tell you that.
And we're doing it.
Everybody except for Peyton, I have something to tell you. Okay, I won't say that we're doing a proof.
You'll write it.
I'm going to give you a picture too, so leave some room over to the right for a picture.
Question, do you like proofs, Mr. Tanner?
Yeah, I like proofs. I like some of them. I like the ones I can figure out. When I get stuck, I really don't like proofs.
Who are you?
Who
A
am I?
math teacher?
I felt bad.
A robot?
Even if you don't like geometry proofs, even if you don't like geometry proofs, I hope you can still appreciate the value of being able to back up what you say with evidence. That is a useful skill. Because I said so is not a valid argument technique, especially against children. That, you know what, as often as your parents say that to you, you'd think they would have figured out that that does not work. Because I said so.
Yeah.
Have you ever had to use that on your children?
I don't, but Mrs. Taylor does sometimes because our daughter is in the why phase. She asks why to everything. And after you answer why about 11 times in a row, you just start saying because,
Because I said so.
or you start making stuff up.
Well, if you lie to your kid, and that develops the
Should make a
habit of lying. Because they're like, oh, my parent lied to me. It's okay if I lie.
I don't think so.
I don't think any child thinks that.
I'm pretty sure, did your parents tell you that? Now you think it's okay to lie, Peyton? Is that what you're trying to get at?
No.
Do you think it's okay to lie, Peyton?
But I mean, what's the reason?
So yes.
What's the valid reason why you did it?
There's never a good reason for dishonesty, Peyton. You should always be honest.
If you're trying to hide a surprise for someone, though.
Yeah.
But you still wouldn't lie. You would
It would be like,
redirect.
so
Redirecting is suspicious.
You're just giving them the wrong information, but they'll find out sooner or later.
What did you get me for Christmas? Oh, I don't know. What do you want for Christmas?
And they'll be like, oh, you didn't give me anything.
Speaking of Christmas, did your parents, when you were younger, do Santa Claus with you?
What?
Did your parents do Santa Claus with you when you were younger?
I did it twice and then
So your parents lied to you.
no. What?
What?
Did your parents tell you Santa Claus was going to bring you toys?
No?
Then what did you mean when you said that your parents did Santa Claus with you twice?
They did twice and then I just figured out that they're Santa Claus.
So your parents lied to you twice.
Wait. Are you saying you figured out that Santa wasn't real when you were 2? Or did you not do Christmas until?
Oh, we did Christmas. I just later on developed, oh. You're not
That's
Santa
not
Claus.
2 years.
Twice, Peyton.
Peyton Santa is real.
Okay. So EG and DF bisect each other at M. EG and DF are the really long, they make the gigantic X shape in our diagram. They bisect each other at M. What does that tell us, that they bisect each other? What does bisect mean?
Me.
Each side is congruent.
Okay, but what does bisect mean? Cuts it exactly in half. So what if EG is bisected, that means that this piece EM must be congruent to MG. And it also tells us that DM must be congruent to FM. Now I don't know they're congruent to each other, which is why I'm doing one line for the first pair and 2 lines for the second pair. They might be congruent to each other, but I can't prove that yet. But what I can say is that DM is congruent to FM, and that EM is congruent to GM. And the reason I know that is because I was told they bisect each other, and that is what bisect means. So I'm going to say the reason I know that is the definition of bisector.
And would you know that angle EMD is congruent to FMG because of the vertical?
Very good. Ellie's got the next step. EMD is congruent to FMG because they are vertical angles. That's going to be our next thing. So angle EMD is congruent to angle GMF because of the vertical angles theorem. I wonder if we should put a step in between saying that those are vertical angles. Probably we should. Probably step 3 should have been EMD and GMF are vertical angles, and then the next step was they're congruent. But you know what? We're fine. You get the idea.
Close enough.
Close enough. So, now what? I'm sorry, that is not a valid statement or a reason. Now what?
You could use SAS.
Yeah, I'm done. I have proved these two triangles are congruent by SAS. Triangle, what was the proof was DEM was congruent to triangle FGM. And the reason why is I'm just going to write SAS. You could write side angle side congruence theorem. That would be okay. Or you could not do that, which is what I'm going to do.
Oh, he just didn't put the line.
Oh, you're right. I'm sorry. I forgot.
Okay, so I'm like,
Nope, you're right. I forgot him.
I forgot his name.
I wasn't going crazy.
Well, I don't think I'd go that far. You could still be going crazy, but you were also right about that. Yeah. Oh man, that really wasn't bad. A little 4-step proof. I think probably that should have been 5. I don't feel good that we didn't say EMD and GMF were vertical angles before we said they were congruent, but you know what? It's fine.
You get the point.
That wasn't too bad. I feel like maybe we should do one more of those.
I disagree.
Oh, well, if this was a democracy, I would take that under advisement.
But it isn't, so we still.
It is not a democracy. It is a dictatorship. Sort of like a monarchy, except instead of being ordained by God, I'm ordained by the principal. Who's kind of like school God.
So I think we were like a school prophet.
School prophet.
Either the board
So-
or the superintendent would be.
Instead of handing out miracles, she hands out like detentions, but still same idea.
Same difference.
Yeah, totally same thing.
She can't walk on water that I know of.
Dang it. If
We could go test this river over there.
Just let's throw her in the river. If she can walk on water, she's school Jesus, and if she sinks, she's a witch. Or wait, as if you float, you're a witch. I forgot.
you float.
We'll decide after
Or
we see what
no,
she
if
does.
you levitate.
Okay, so UV and WX are parallel. That was given. So I think we can safely put that as our first statement.
You didn't label any of the angles.
What do you mean?
You just label which angle it was. Or side, yeah.
Yes, I did. They're right there. I'm a trifle deaf in one ear. You'll have to speak up next time. Number 1, UV parallel to WX because given.
We put on the diddly do.
The arrows mean that they're parallel to each other. Those are the diddly doos. The little lines are the doodly dids. What do those mean? They're congruent. So we're gonna, that's also given by the diagram, not by a statement. So that'll also go with the given.
Taylor,
Yes?
why can't you, like on, for the proof, like on triangle Y, not Y, U, X, Y, W, can't you, like, is it okay if you switch it up and like U, like X, W, U? Or does it have to be that?
You mean if you labeled it differently than me? That's
No,
a,
like, not label it, but like on the statement, you say X, W is.
oh, sure.
parallel to-
As long as you switch both of them, because remember, order matters. So if you do VU and XW, that's okay. But if you did UV and XW, that might be problematic. We want to keep them in the same order. Okay, what else you got? While you're thinking about what else you got, this is really bugging me. That is unusually bad. Stop being mean to me. It's not unusually bad. It's standard Taylor level of bad. So mean. Okay.
I mean, we're being nice to you, but also mean in this sense.
Okay, great. Thank you. What else do we know? What else do we know besides you guys are mean about my drawings?
Oh, if that's like that, then that's like that.
We have parallel lines,
Then,
which means we,
UW is a transversal.
UW is a transversal. Would, so then the angle stuff. Which angles can we prove are congruent if UW is a transversal?
So here UW and UW that.
Yes. Good job, Ellie. Angle
Sine
VUW is congruent to angle XWU. How do we know that? What kind of angles are those?
That's right, alternate interior.
Very good, Ellie. The alternate interior angles theorem. You could just write alternate interior angles. That would be okay. So that and that. God bless you, my child.
Is that enough to prove that they're congruent?
We have one side and one angle for both triangles. We need one more side.
Question, why is it?
How?
The bottom side, or the transversal, if it's transversal, would be the same for both because it's reflected.
Yes, the transversal UW is a side that both triangles share. So we know that's got to be congruent in both triangles. And now, not only are we going to write that they're congruent, but our reason is going to be one of my favorite math theorems of all time, or not theorem, property. UW is congruent to WU. Something is congruent to itself.
Corresponding angle.
Nope.
Is that the thing?
When something's equal to itself. I told you it was silly at first. You're like, why do we have to say that X is equal to X? Of course it is. Now you know why. We learned that dumb property for proofs. What's the property? First, I'm gonna flex, and then I'm gonna reflex. The reflexive property.
Yeah.
If you flex twice, the second time it was a reflex.
Wow, that was just stupid.
That was good.
It was.
Don't forget to smash that like button for more comedy.
It
Is
was-
that enough to prove that these two triangles are congruent by SAS? Yes. We have two congruent sides in each one and the included angle. So that is enough to prove our statement. Triangle UXW is congruent to, I'm just copying this from the prove line in the original problem, WVU. And the reason is the side angle side congruency theorem, or SAS for short. And in the words of Gandhi, this is how we do it. I always get mixed up. Is that song Montel Williams and then Montel Jordan was the talk show host, or is it the other way around?
No, you gotta search it up.
Montel Williams and Montel Jordan. One was a singer and one was a talk show host.
Montel Jordan was a singer.
So Montel Williams is the talk show host. You learned two things today, the SAS property and a little bit of 90s trivia.
Yeah.
I mean, you don't have to put marks on anything. It just helps you see which congruent pieces we had. You don't have to put marks anywhere. Nobody can make you do anything against your will. Be quiet. Oh, I can make you do something against your will. Any questions from anybody about anything?
Is that all we're doing today for math?
That's all we're doing today for math.
Yes.
Tomorrow I'll teach you a couple of new theorems besides SAS.
Aww.
Are they easier or more difficult?
They're the same.
Okay.
They're all the same. They're all the same level of difficulty. But the more you have, the easier it is to prove triangles are congruent. It means you could be given a tiny amount of information and use one of those theorems to answer your question.
Are we going to eventually break?